On April 8, 1945, soldiers of the 354th Infantry Regiment of the United States Army burst into the territory of the Gotha Aircraft Factory, hidden at the very edge of the Thuringian Forest in the small German town of Friedrichroda. For 3 consecutive days, the Americans gnawed through the German defense, lost men, and ran into ambushes. Finally, the factory was taken. But what the fighters saw inside the workshops made them stop and fall silent. On the concrete floor stood 4 strange aircraft, looking not like airplanes but like giant steel stingrays. These machines had no tail, they had no familiar fuselage, only wings, huge, swept, merging into a single body, inside of which was hidden the pilot's cockpit and 2 jet engines. Nothing of the kind had anyone in the American military seen before. The infantrymen, accustomed to the sight of ordinary Messerschmitts and Focke-Wulfs, simply did not understand what was in front of them. In front of them stood a weapon that could change the entire course of the air war if Germany had received at least a few more months. The command reacted instantly. Within a matter of days, a special group from the 8th Air Force of the United States arrived at the factory, working within the framework of the top-secret Operation Paperclip. The task of this operation was simple and cynical: to take for themselves all the most valuable of the German military developments before anyone else could do it, and primarily before the Soviet Union could do it. Specialists inspected all 4 machines, selected the most complete specimen, and ordered it to be sent immediately to America. The remaining 3 prototypes were ordered to be destroyed on the spot, so that not a single sample would fall into the hands of the Soviet troops rapidly advancing from the east. Separately, 75 miles from the factory, the American Army discovered a pair of huge wings manufactured for this same project. The wings were also loaded and sent along with the fuselage across the ocean for thorough study. America received a trophy that would define the future of world aviation for decades. But what kind of aircraft was it? And how, in the ruined, bleeding Germany of 1945, could they create something so fantastic? To understand this, one needs to go back a decade and a half to the beginning of the 30s, when 2 young Germans by the surname of Horten began their journey into aviation. Reimar and Walter Horten were biological brothers, and both had been obsessed with the sky since childhood. Reimar was a dreamer and a brilliant designer of the type of people who see the shape of a future airplane with their eyes closed. Walter was a daring pilot, ready to lift into the air anything his brother drew, even if it looked like complete madness. Together they formed a tandem in which the talent of the designer was backed by the fearlessness of the test pilot. It was precisely this tandem that allowed them to perform the impossible. In those years, Germany, under the terms of the Treaty of Versailles signed after the defeat in the First World War, did not have the right to create military aviation. The ban was harsh and humiliating, but the Germans found a way to bypass it. Throughout the country, so-called sports glider clubs began to open, where formerly young people learned to fly harmless gliders, but factually the future military aviation of Germany was being forged. It was in these clubs that the Horten brothers began to build their first aircraft. It was there that Reimar first caught fire with the idea that would become the work of his entire life, the idea of the flying wing. The concept was simultaneously simple and revolutionary. A conventional airplane consists of a fuselage, wings, and a tail assembly. But if you think about it, only the wings create useful lift. The fuselage is needed to accommodate the crew and cargo. The tail is needed for stability and control. But both the fuselage and the tail create enormous aerodynamic drag, slow the plane down, consume fuel, and add weight. What if you remove everything superfluous and leave only the wing? Accommodate the crew, engines, fuel, and armament right inside the wing, and replace the tail with a clever aerodynamic shape that will provide stability by itself. Such an airplane will be lighter, faster, more economical, and at the same time will be able to fly further than any analog with a conventional layout. It sounds like science fiction, but Reimar Horton was convinced that it was possible. Throughout the 30s, the brothers built a whole series of experimental gliders with a flying wing, each of which became more complex and perfect than the previous one. They learned from their mistakes, refined the aerodynamics, and searched for that very ideal wing shape that would allow flying without a tail. By the beginning of the 40s, when Germany was already waging a world war, the Horton brothers had accumulated unique experience that no one else in the world had. They knew how to make a flying wing work. They only needed a chance to prove it. The war provided this chance. By 1943, the situation in the air over Germany had become catastrophic. Thousands of heavy Allied bombers, day and night, were turning German cities into ruins. Factories, power plants, railway junctions. All this was methodically destroyed by carpet bombings. There was practically nothing left for the Luftwaffe to stop this fiery conveyor belt. Fighters with piston engines were becoming hopelessly outdated, and anti-aircraft artillery could not cope with the armadas coming at high altitude. Germany needed something fundamentally new, and it was needed urgently. It was then that Reichsmarschall Hermann Göring, who commanded all the air forces of the Third Reich, announced a competition that went down in the history of aviation under the short and concise name 3x1000. The requirement sounded simple, but behind this simplicity was hidden an engineering task on the verge of the impossible. Göring wanted an airplane capable of carrying 1,000 kilograms of bombs over a distance of 1,000 kilometers at a speed of 1,000 kilometers per hour. Each of these requirements individually was a serious challenge, but all three simultaneously seemed like fantasy. 1,000 kilometers per hour in 1943 was a speed inaccessible to any serial aircraft in the world. Only jet engines could achieve it, but they devoured kerosene at a monstrous rate, which made the range requirement almost impossible to fulfill. It turned out to be a vicious circle. To fly fast, you need jet motors. To fly far on jet motors, you need so much fuel that the plane will become too heavy and slow. Aircraft designers of Germany, one after another, refused to participate in the competition, recognizing the task as unsolvable with existing technologies. But the Horton brothers saw in these requirements not a dead end, but a confirmation of their rightness. All their years of experiments with the flying wing led precisely to this moment. A machine without a fuselage and tail has such a small aerodynamic drag that with the same engines, it will fly significantly further than a conventional airplane. The fuel saved on overcoming frontal resistance turned into those very missing kilometers of range. The flying wing was the only layout capable, at least theoretically, of reconciling the speed of a jet engine with a flight range of 1,000 kilometers. Reimar and Walter submitted their project, and it turned out to be the only one of all those proposed that even approached fulfilling Göring's requirements. The Reichsmarschall was impressed. The Horton brothers received 500,000 Reichsmarks, and in order to build several prototypes and lift them into the air as quickly as possible. For a warring Germany that was already experiencing a shortage of resources, this was a huge amount of money and enormous trust. Now it was necessary to justify it with action. The airplane that the brothers began to design was completely unlike anything that existed in the aviation of that time. If you looked at it from above, it resembled a giant bat with a wingspan of 16.8 meters. The length along the central axis was only 7.4 meters, and the overall height did not exceed 2 meters 81 centimeters. The pilot's cockpit, recessed into the central part of the wing, was so cramped that the pilot literally rested his helmet against the canopy. The height of the cockpit was only 1 meter 10 centimeters, and only one person could be in it. But the Horton brothers did not need comfort. They needed speed. The key engineering solution was the shape of the wing. Reimar developed the so-called bell-shaped lift distribution, which decades later NASA specialists would call brilliant. The essence was that the wing was long and thin, with a high aspect ratio, and its profile changed from the center to the tips according to a special law. This shape solved two problems at once, from which all previous attempts to build a flying wing had suffered. Firstly, it provided stability without a tail assembly. The airplane did not yaw from side to side and did not tend to spin. Secondly, it radically reduced the induced drag at the wingtips, which added both speed and range. But the real surprise was the materials. In conditions of a total shortage of metal and resources, when Germany was literally suffocating under bombings, it was impossible to build an all-metal airplane. The Horten brothers found a way out that turned out to be not just a necessary measure, but an unexpected technological breakthrough. The wings were made of plywood impregnated with carbon dust, and they were glued together with a special composition based on sawdust and charcoal. Cheap, accessible, and strikingly effective. Much later, already in the 21st century, researchers would discover that this carbon impregnation absorbed radar waves, making the aircraft significantly less noticeable on radar screens. The Horten brothers did not design a stealth aircraft deliberately, but accidentally created a technology that the rest of the world would reach only 40 years later. Two Junkers Jumo 004B turbojet engines were chosen as the power plant, each with a thrust of about 883 kilograms. They accelerated the machine to a maximum speed of 960 kilometers per hour and provided a range of 1,900 kilometers, which was almost double Göring's requirements. The practical ceiling reached 15,000 meters, and a brake parachute deployed from the rear of the wing was used for landing. The armament consisted of two 30mm cannons, which, according to the calculations of the German military, were sufficient to destroy heavy bombers. The machine was ready to fly, and now the word was up to the test pilots. The first prototype, designated as Vone, was built without engines. The jet motors intended for this machine turned out to be too large and simply did not fit into the thin wing profile. The Horten brothers decided not to wait for the modification of the motors and to use the first specimen as a glider to test aerodynamics and controllability. On March 1, 1944, at the Oranienburg airfield near Berlin, this strange motorless apparatus lifted into the air for the first time under tow behind another airplane. The pilot unhooked the cable and found himself one-on-one with a machine that flew contrary to all conventional laws of aviation. No tail behind, no fuselage underfoot, only a wing rushing over the airfield. A series of glider tests continued all through the summer of '44, and the results exceeded even the wildest expectations of the designers. The machine was stable, obedient in control, and demonstrated excellent flight characteristics. The bell-shaped wing profile worked exactly as Reimar Horten had calculated. While the glider was proving the viability of the concept in the sky over Oranienburg, the assembly of the second prototype, V2, was in full swing on the ground. This specimen was already equipped with two turbojet engines, and it was the one that had to prove that the flying wing was capable of not just soaring, but rushing at near-sonic speeds. An experienced test pilot sat at the controls, Lieutenant Erwin Ziller, one of the few Luftwaffe pilots who had significant flight time on jet machines. On February 2, 1945, Ziller taxied onto the runway, gave full throttle to both engines, and lifted the machine into the air. What happened next made an impression even on experienced aviation engineers. The flying wing climbed with a roar, easily accelerated, and demonstrated maneuverability that no one expected from an apparatus of such an unusual shape. Ziller spent about 2 hours in the air, performing various flight regimes and checking controllability at different speeds. According to available data, it was during this period that the Germans conducted a comparative test of the flying wing with the Messerschmitt Me-262 jet fighter, which was considered the pride of the Luftwaffe and the most advanced combat aircraft in Germany. The result of the comparison turned out to be stunning. The Horten demonstrated better controllability than the Messerschmitt. For a machine built of plywood and glue in semi-artisanal conditions, this was a fantastic result, confirming the accuracy of all those calculations that Weimar had been making over the last 10 years. Göring was delighted. The Reichsmarschall immediately signed a contract for the production of 40 serial machines. 20 of them were to become single-seat fighters capable of intercepting Allied bombers at a huge altitude. The pilots of these machines were to wear special high-altitude suits from the Draeger firm, since the working ceiling of 15,000 meters was far beyond the limits of the human body's capabilities without additional equipment. The machines were also equipped with an ejection seat, which was a rarity for the aviation of those years, and a brake parachute to shorten the landing run. The emergency serial production program was launched on March 12, 1945, when less than 2 months remained until the end of the war. But 16 days earlier, a tragedy occurred that dealt a terrible blow to the project. On February 18, 1945, Erwin Ziller lifted the V-2 prototype into another test flight. Everything was going normally until, at a certain stage, one of the 2 engines failed. The Jumo 004 jet motors were capricious and unreliable aggregates that suffered from chronic problems with turbine blades, and the failure of one of them was not something unexpected. But landing a flying wing on one operating engine turned out to be a task for which even such an experienced pilot as Ziller was not prepared. The machine with asymmetrical thrust began to go to the side, and Ziller failed to level it. The airplane crashed to the ground and was destroyed upon impact. The test pilot died. The death of Ziller was not just the loss of a brave man. Along with him, the only flying specimen with engines was destroyed, and along with the specimen, priceless data on the behavior of the machine on jet thrust. It seemed the project was doomed, but Göring, contrary to logic and common sense, reacted to the catastrophe in a completely unexpected way. He did not close the program, but on the contrary, increased the order by another 20 machines, bringing the total number to 60. Production was urgently transferred to the Gotha factory in Friedrichroda, away from the front line. The Germans desperately clung to the last hope of turning the course of the air war, even if this hope was made of plywood and flew without a tail. At the Gotha factory in Friedrichroda, feverish work began to boil. Engineers of the Gothaer Wagenfabrik Company, who usually produced railway cars and during wartime switched to the production of aviation equipment, received the drawings of the Horten brothers and began to adapt them for serial production. The fact was that Weimar's original designs were the work of a lone genius, calculated for piece-by-piece manual assembly. For mass production, a serious redesign of the structure, simplification of technological processes, and standardization of parts were required. Gotha's engineers worked on this parallel to the assembly of new prototypes, and several machines for different purposes were being built at the factory simultaneously. The V-3 prototype was the most advanced of all. It was equipped with improved Jumo 004C engines, which were more powerful and reliable than their predecessors that killed Ziller. A full-fledged pilot ejection seat was integrated into the design for the first time, something none of the previous specimens had. In essence, the V-3 was to become the standard for a serial single-seat fighter, that very interceptor capable of climbing to 15,000 meters and attacking formations of heavy bombers with its 30mm cannons. But the Germans did not intend to limit themselves to one variant of the fighter. The V-4 and V-5 prototypes were designed as 2-seat machines. Unlike the single-seat interceptor, they were conceived as all-weather night fighters, capable of operating in the dark and in difficult weather conditions. The second crew member was to work with the airborne radar station, detecting targets in conditions of zero visibility. Night bombings were a real scourge for German cities, and while day raids could somehow be parried by anti-aircraft artillery, at night the bombers operated almost with impunity. A 2-seat Horten with a radar on board could become the answer to this threat. The V6 prototype returned to the single-seat layout, but differed from the V3 by reinforced armament. The German military wanted a machine with more powerful cannons, capable of guaranteed destruction of 4-engine bombers from 1 or 2 bursts, without wasting time on long pursuits and repeated passes. Every second in a battle against a tight formation of bombers, bristling with dozens of defensive machine guns, could cost the pilot his life. Therefore, maximum firepower with minimum contact time was an absolute priority. Parallel to the factory bustle in Friedrichsroda, plans far more ambitious than just the defense of the German sky were unfolding in the offices of Berlin. The leadership of the Luftwaffe considered the Horten not only as a fighter interceptor, but also as the foundation for a whole family of next-generation aircraft. If the machine proved its effectiveness against bombers, why not go further? A flying wing with its fantastic range and low radar visibility could become an ideal platform for a strike aircraft capable of delivering a bomb strike on England and returning to base without refueling. If one scaled the structure, increased the dimensions, and installed more powerful engines, then theoretically one could aim at targets on the other side of the Atlantic. The range of 1,900 kilometers in the basic version of the fighter left a colossal margin for growth, with an increase in the size of the machine. The idea of a transatlantic bomber was not pure fantasy. The German command was seriously developing the so-called America bomber, a project for an ultra-long-range airplane capable of reaching the eastern coast of the United States. Several design bureaus offered their variants, but all of them suffered from the same problem: a monstrous fuel consumption to overcome thousands of kilometers over the ocean. The flying wing of the Horten brothers, with its minimal aerodynamic drag, looked like the most promising basis for such a machine. If Germany had received enough time, the technology could have gone far beyond the framework of a fighter interceptor. But Germany had no time left. By March 1945, the front was bursting at the seams. From the west, American and British armies were advancing, having crossed the Rhine. From the east, Soviet troops were marching in an unstoppable avalanche, grinding down the remnants of the German defense. The Allied bombers, the very ones against which the Horten was intended, continued day after day to destroy German industry. Factories producing components for the flying wing, one after another, went out of operation or fell into the combat zone. Transport communications were destroyed, deliveries of materials ceased, and qualified workers went to the front or died under bombs. The emergency production program for fighters, which in addition to the Horten included the jet Heinkel He-162 Salamander, was stalling in all directions. The Heinkel at least managed to reach combat application, albeit in tiny quantities. The Horten was hopelessly lagging behind, and not a single serial specimen ever lifted into the sky. The steel ring around the Third Reich was tightening with each passing day, and the plywood miracle of the Horten brothers had only a matter of weeks left to live. While the American infantry was storming Friedrichsroda, another hunt for the secrets of the flying wing was unfolding on the other side of the front. The British Combined Intelligence Objectives Subcommittee, operating parallel to the American Operation Paperclip, was conducting its own search for German aviation technologies. On June 11, 1945, 2 months after the capitulation of Germany, British intelligence officers discovered a real treasure in the locality of Treffert on the Neckar River, approximately 100 kilometers southwest of Stuttgart. On towing trailers, camouflaged between trees, stood 3 fully equipped gliders of the Horten brothers' design. All instruments were in place, all control systems preserved, and the documentation was neatly laid out nearby. Someone from among the German technicians had clearly taken care to ensure that the machines survived the chaos of the last days of the war intact. The British thoroughly inspected the find and compiled detailed reports, but in the end made the decision to hand over all 3 gliders to the Americans. The machines were loaded and sent across the ocean to the Wright Field Base in Dayton, state of Ohio, where the main trophy, the V-3 prototype from the Gotha factory, was already located. It was Wright Field that was the center for studying captured foreign aviation equipment, and everything most interesting found by the Allies on the territory of the defeated Third Reich was brought there. Specialists of the Foreign Aircraft Evaluation Branch received at their disposal a unique set, a jet-flying wing and a set of gliders of the same design, on which one could, without risk, master the piloting of an unfamiliar layout. American engineers disassembled the V-3 literally to the last screw. Each element of the structure was measured, weighed, photographed, and described. Particular interest was aroused by the wing skin, that very plywood with carbon impregnation, glued with a composition based on sawdust and charcoal. The Americans quickly realized that this cheap material possessed properties that the Horton brothers themselves might not have suspected to the full extent. The carbon impregnation absorbed radar waves, and moreover, did it at those frequencies that were used by the Allied radars. The plywood airplane from ruined Germany turned out to be the first aircraft in history with elements of radar cross-section reduction technology, albeit created not intentionally, but out of necessity due to a shortage of aluminum and steel. The data obtained landed on the table of designers who were already working on their own flying wing projects. One of them was Jack Northrop, an American aviation engineer who, since the 30s, had been following the experiments of the Horton brothers with their sports gliders. Northrop was developing a heavy bomber according to the flying wing layout under the designation XB-35. It was a huge machine with propeller engines, and it suffered from powerful vibrations that could not be overcome. The project was stalling, and the data obtained during the study of the captured Horton came in very handy. Later, the XB-35 was modernized, replacing the piston engines with jet ones, and the machine received a new designation, YB-49. The Horton brothers turned out to be right initially. The flying wing truly revealed its potential only with jet thrust. But the real embodiment of the ideas of Reimar and Walter Horton was seen by the world only a decade later. In 1989, the Northrop Company, the successor to Jack Northrop's business, lifted into the air the strategic bomber B-2 Spirit. This airplane, which became a symbol of American military power at the turn of the century, was executed according to the flying wing layout. Its smooth contours, the absence of a tail assembly, and the combination of aerodynamic perfection with stealth technology. All this was a direct continuation of that line that two German brothers began in the glider clubs of the 30s. The similarity between the plywood Horton of 45 and the titanium B-2 of 89 was so obvious that aviation historians directly called the German machine the progenitor of the American stealth bomber. However, the idea of a flying wing belonged not only to the Horton brothers. The German aviation engineer Hugo Junkers patented the concept of an airplane without a tail and fuselage back in 1910, 2 decades before the first experiments of Reimar and Walter. The Horton brothers took this idea and brought it to a completely new level, creating the world's first jet-flying wing. 44 years after the plywood prototype crashed along with Erwin Ziller at a German airfield, their legacy lifted into the sky in the form of the most expensive and technologically advanced combat airplane on the planet.